Thanks everyone so much for joining to our talk on the Python SDK, which is a tool that will make writing Airflow DAGs even more easy for you. Now, before we're going to get started, I wanted to quickly explain, since all the slides are Astronomer branded, who is Astronomer and who are we who are talking to you today. So you probably have heard about Apache Airflow. Maybe you haven't used it yet. Don't worry, we will explain all the basics you need to get started. But Apache Airflow is an orchestrator, and Astronomer is the commercial developer behind Apache Airflow. So currently around 50% of the commits to the Airflow project come from Astronomer employees. And we also build tools on top of open source Airflow, including tools aimed at improving the developer experience, like the Python SDK that we're presenting to you today. While of course Astronomer has a commercial offering, I want to stress that today everything you are going to see in this talk is fully open source and fully available to you. My name is Tamara, and I'm a developer advocate at Astronomer. In terms of background, I actually am coming from a completely different field. I originally was in medicine, and I started learning Python to get better at science, write better scientific papers, and do better statistical analysis. And it was just so much fun that I kind of couldn't stop. And that's how I ended up working for Astronomer, and I'm loving it. And Daniel, do you want to introduce yourself real quick?
Yeah, of course. Hi, everybody. My name is Daniel Imberman. I'm the strategy engineer at astronomer.io, and I'm also a PMC member on the Apache Airflow project. I've been working with Airflow since about 2015. Some of my personal favorite highlights is co-leading the creation of the Kubernetes executor, as well as being one of the release managers for Airflow 2.0. And now at Astronomer, my main goal is trying to figure out how to create a better developer experience for people writing Airflow DAGs. And that's where the Astro SDK comes from.
Thank you, Daniel. Okay, so let's get started with what is Airflow. You probably have processes in your life and in your work experience that have some steps automated, but the parts that always take ages are the steps that aren't automated yet. And Airflow is all about minimizing these manual parts and creating more complex automations with more complex dependencies in your life. In one sentence, Apache Airflow is an open source tool for programmatically offering, scheduling, and monitoring your data pipelines or any of your Python code. I put this here in parentheses because I think you always hear of Airflow in terms of data engineering, which is one of the core use cases, but you can also schedule anything that you can define in Python and any code that you have, if you currently have Python scripts somewhere, with Apache Airflow. It's downloaded over 12 million times per month, which makes it the most popular open source choice for workflow orchestration. Some of the reasons why it's so popular is that in Airflow itself, the pipelines are written as Python code. So you can do all the things that you can do with your Python code, also with the Airflow code itself. For example, having CI/CD or define your custom classes and building on top of it. So it's highly extensible. And Airflow is also infinitely scalable. Actually, if you've been following the conference on Wednesday, Calvin did a talk on how to scale up DAG factories and DAG creation. So if you're interested in scaling, that's something to check out. And with 12 million downloads per month, you can imagine there's a pretty big community of heavy Airflow users. And if you run into an issue and want to learn something more, you can almost always find an answer on the Airflow Slack. Now, I said it before, if you can define it in Python, Airflow can orchestrate it. So you can imagine there's a ton of different use cases that people have found for Airflow. This is actually even true for things that you're defining in a different language because you can orchestrate Docker images with Airflow quite easily. Since it was developed in the data engineering space, ETL and ELT is still one of the core use cases that Airflow is being used for. But a lot of people now use it for ML ops or to automate their backend processes and just in general automate the boring parts of life. Now, this is the Airflow UI. I will not go into detail on what you see here. I put the slide here, especially for people who may have used Airflow 1.10 or earlier versions, so that you can see how much has changed in the UI. You have a ton of observability about the past runs of your DAGs. A DAG is the unit of a workflow in Airflow. If they failed, when the next one is going to happen, what the schedules are, you can turn your DAGs on and off. So there are a ton of things you can do in your orchestration from the UI. And now if we would click on one of these DAGs, we could get even more information. If you haven't used Airflow yet and you are not coming from a mathematical background, you might be wondering what DAG means. DAG stands for Directed Acyclic Graph. So you have a graph with edges and nodes. The nodes are the tasks and the edges are the dependencies between them. On the right-hand side here, you can see a very simple DAG. We have two nodes, two tasks, one edge between them, and the edge defines the dependency. So extract, the task that is defined as extract, needs to happen before the task called write to min.io. And the requirements to define an Airflow DAG are simply that all the edges need to be directed. So you can never have an edge that goes both ways, and you cannot define circles. Airflow will tell you if you accidentally have defined a circle in your DAG. All right, so we have this very basic DAG with just two tasks. And on the left-hand side, I've shown you all the code that is needed to define this DAG. So if you've never used Airflow before and you think, well, maybe I have this whole stack of Python scripts that I could really use to be orchestrated better, it's actually quite simple to get started. You can see on line 8, I have the @DAG decorator. And I put this on top of a normal Python function, and this will tell Airflow that if this file is within the DAGs folder in an Airflow project, now a DAG is starting in this Airflow file, and Airflow will pick up the code that is in here and transform it into a DAG. There are two mandatory parameters here, schedule and start date, and there's of course a ton of customizability if you want to, but this is all that you need to define your DAG. And then within that function, that is your DAG, you can start defining your tasks. On line 15, you can see a normal Python function that posts a GET request to an API and returns the payload. And I just put the @task decorator on top of the function. And now Airflow knows, okay, this is a task. I need to create a task from this that is called extract. I use the same name. And when this task runs, I run everything that is in this Python function. So these are the very basic building blocks to get started. And then, as you can imagine, there's a lot of code that you don't want to repeat. So what happens is that people have defined operators. An Airflow operator is simply a Python class that abstracts over a task that you might want to do repeatedly. So here I use the local file system to min.io operator, which takes in a JSON serializable information and puts it into a min.io bucket. And you can see I only provide some parameters. I don't even think about the min.io API. I don't have to do a direct call. And the AstroPython SDK is one of those packages that contains a ton of operators that do a lot of things for you. All right, this is a very simple DAG, but of course, a DAG can be as complex as you want it to be or as you need it to be. And there are some more visual features like task groups that you can see here. And as long as it's always directed, so we always go into one direction and we have no circles, you can define your workflow as a DAG or within several DAGs. Okay, before we jump into AstroPython SDK, you can imagine there are a ton of features that Airflow has on top of this, but I wanted to quickly highlight three core features, which are important for you to understand the following slides. So the first of them are Airflow connections. An Airflow connection is how you can store your credentials in Airflow to authenticate to a different service. So if, for example, to a Postgres database, you could define a Postgres connection, put all your credentials and your secrets in there, and then whenever you need to connect to that Postgres database, you simply use the connection ID. And usually in Airflow, the parameter that you provide this connection ID to is either called con ID or something like here in the blue square HTTP con ID. The secrets itself can be stored directly in the Airflow connection in the Airflow Metastore or within the secrets backend. The second thing that I wanted to mention is dynamic task mapping. This was added in Airflow 2.3 and has been a huge game changer in terms of how Airflow can be made dynamic. Now, if you've seen the talk on Wednesday, you have heard the word dynamic in the context of dynamic DAGs. Dynamic tasks is something different. Dynamic DAGs refers to programmatically creating your DAGs. So you have code that creates your DAG code. Dynamic tasks are tasks within your DAG code that sit there as sort of a placeholder when you don't know how many tasks or how many iterations of a task you will need at runtime. So for example, the task that you see on the slide queries an API, and you can see the parameter that I put into this function is called endpoint. But what if I don't know how many endpoints I want to hit every time this task runs? So maybe I have this DAG running every 15 minutes, and sometimes I want to hit no endpoint, and sometimes I want to hit 1,000 endpoints. But I don't want to change the DAG code every 15 minutes. That wouldn't be feasible. So what I can do now in Airflow 2.3 is I add the .expand function, and then I provide a dynamic list of objects to the endpoint parameter. So here I provide the get endpoints task. So I have an upstream task that figures out which endpoints to hit in this DAG run. And this can change with every run of the DAG. And you still have full observability in your historical DAG runs. If you go back, you can see one time 1,000 endpoints were hit, and you can have the logs for each of the endpoints separately. And this is something that is extremely powerful when combined with the AstroPython SDK. Lastly, the last core feature I want to mention, because it's been highly requested, you can now use IDE Python debugging with your Airflow DAGs by using the dag.test function. Daniel is going to show you an example of using this with the AstroPython SDK. It has been very recently added in 2.5 and something that we're super excited about because it just makes the developer experience so much better. Talking about developer experience, if you've ever had to move data from one format to another, from one storage to another, you quickly run into a lot of issues and things that you need to think about. For example, you need to think about staging tables, intermediary storage. At one point, you probably have realized, oh no, I've created a ton of temporary tables that I now have to clean up. You have to think about setting the dependencies right. Even sometimes about SQL dialects or how to define the schemas by hand. And at one point, you end up thinking, I really just want to use Python. I don't want to think about all these intermediate steps every time, and I don't want to have to change them every time I make some changes to my infrastructure. This is exactly the issue where the AstroPython SDK comes in, and the problem that led to the development of the AstroPython SDK. Now, what is the AstroPython SDK? It is DAG offering for everyone reinvented. So the SDK team wanted to give you the ability to write self-documenting and especially database agnostic Pythonic code. So you should be able to use your Python skills and ways that you like to write to define your code that moves data from one place to another, that transforms data, analyzes it, and if you ever need to change your underlying relational database or pull in a different database, for example, you're changing from Snowflake to Postgres, you should not need to make any changes to your code other than pointing at a different database. The second goal was that you should be able to move seamlessly between relational stores and Python data structures. So everyone who has done data science knows this problem. You have your data in a relational store, you query it using SQL, then you transform that into a Python data frame, you do your transformations, and then you need to put it back into SQL. That's usually the painful part. And the AstroPython SDK seeks to abstract away all these transformations so that you barely know anymore what you're working with because it's so easy to switch between Python data structure and relational data structure. And lastly, whenever you want to load a file, either from local or remote storage, or export a file, for example, you have a file in an S3 bucket, a CSV file, you want to load it into your Postgres database, this should not be painful. You should not need to think about, okay, how does this specific database handle this specific file type? What do I need to define? This should be possible in one line of code. In one sentence, the AstroPython SDK is a Python package built on top of OSS Airflow to allow you to focus on Python code and pipelines, not on Airflow itself. And of course, it was developed by Astronomer, but the AstroPython SDK is fully open source, and you're also welcome to contribute if you want to. And with that, I'm going to hand it over to Daniel. I'm going to stop sharing my screen.
Awesome. Thank you. Thank you so much, Tamara. Yes, as Tamara said, the AstroPython SDK is fully open source, specifically with an Apache 2 license. So, it is as open source as the Apache Airflow project. You can absolutely contribute to it, fork it, do whatever you want. We are excited to see what use cases you all come up with. But let's dive in a little bit about what the Astro SDK does and how we can best use it to fit our use cases. So as mentioned, one of the most common use cases for data engineers when it comes to using Apache Airflow or building data pipelines in general is the case of ETL or ELT. And in both those cases, if you want to have a series of SQL statements that are able to kind of come together and create like ultimately a SQL pipeline, you have to kind of create temporary tables in between those steps. And that can be kind of cumbersome if you are personally managing those tables. So in this use case, we're talking about load data from S3 to Snowflake, create a temp table, filter the data, create another temp table, join once again. And this can all be pretty cumbersome if you are the one that has to manually do it. And so with the Astro SDK, we really kind of wanted to think of, great, what does it look like for us to abstract as much of this as possible to basically kind of almost create a Spark-like experience, like a Python SDK, like just a simple Python program where anyone who knows Python and doesn't know Airflow should be able to read this and understand exactly what's happening. So we're going to have a very straightforward ETL/ELT use case, which is extract, filter, analyze, bring stuff back together, and then load it into a reporting table. So that's a very common use case, especially for things in ML. You might want to pull things in, run your inference, and then have like a daily reporting table that shows what the results over time are. In this case, sorry, I'm skip this slide. This is the use case we want to kind of go with to tell the story of like what we're doing here. I am a data scientist on a marketing team who wants to perform sentiment analysis of Reddit posts about Airflow. I need to get raw data from the Reddit API, put it into Snowflake, cleanse it, pass it through an inference model, and then merge the results back into a reporting table. And so with that, let's start with what's probably the most important, but also kind of the nastiest part of the pipeline, which is extracting. How do you get data from the Reddit API into Snowflake? Well, traditionally, forgetting even getting the data into something like S3 beforehand, let's just even talk about getting data from S3 to Snowflake. If you were using traditional Airflow operators and you wanted to move data from S3 to Snowflake, you have to first create a temporary table in Snowflake, knowing ahead of time what the schema is, and then be able to manually take an S3 to Snowflake operator to take the data from S3 and pass it in. And there's a lot you have to know here that's both Airflow and about the underlying systems. You have to first know that an S3 to Snowflake operator exists and hope that an operator exists to move data from your data store to Snowflake. So if you're doing GCS and there's no GCS to Snowflake operator, you're kind of out of luck. You then have to manually add your staging table. You need to fill in the temporary table. And then once you've created these two operators, you have to then basically set the dependency manually. And this is, again, Airflow specific knowledge, because these two tasks have nothing to do with each other, except for the fact that you set a dependency saying task B depends on task A. There's nothing smart happening here. There's no use of the fact that these are both running in Airflow. They're both just two very independent tasks that happen to have a dependency on each other. By contrast, with the Astro SDK library, you're just able to run aql.loadfile. And all aql.loadfile cares about is where does the data come from and where is it going? So in this case, we're pulling data from S3. So give us the URL, give us the S3 URL to the file or bucket you want to load from, and then give us the connection ID to the AWS. And then as far as the output table, give us the connection ID to Snowflake. And you can even decide whether or not you want this to be a temporary table or an actual table. So if you give us a table name, we will assume that the table you're passing to is a table you want to exist in perpetuity, versus if you give us no name, we create a temporary table that we assume you want cleaned up at some point during the DAG run. So in the Astro SDK, there's two main data types you have to know about, and that's basically just files and tables. Files can point to a local or remote file. They can be loaded from either local or an object store, or we even have support for loading directly from HTTP. And we support multiple formats, which we'll go over later, but notably CSV, ND-JSON, and Parquet. And then when it comes to a table class, a table is basically a pointer to a table in a data warehouse. So you can give us the schema, you can give us the database, you can give us any metadata necessary to find that table or create that table where you want it with the information you want on it. And again, if you leave it nameless, we will create a temporary table that will exist for the duration of the DAG run. We've tested all of these at scale, and when it comes to loading files, we found very similar numbers to what you would expect from a native tool like BQ load and Snowflake copy. And wherever possible, we take advantage of native features for different combinations. So for example, if you're loading data from S3 to Snowflake, we know how to take those credentials and automatically create a staging table for you. So wherever possible, we optimize our system to give you as fast of loading as possible. But you might not be necessarily using a database. You might just want to be writing a Python program, and that's also fine. And so with AQL.load file, if you don't specify an output, we just assume that you want to store it as a data frame. And when you set up the Astro SDK, you give us a backend storage. So it'd be S3 or GCS. You give us some like default backend storage, and we can actually store data frames for you that gets transferred between tasks. So in this case, we load a file of Reddit data from S3. There's no database. It gets stored as a data frame. And then we can use AQL.DataFrame, which we'll talk about more, to then take that data frame and run Python transformations on it. Now, the AQL.DataFrame function is pretty interesting in that you can actually also use it as its own form of ingest. So let's say you want to take data directly from Reddit, but you want to modify it in a special way. So in this case, you want to do pre-cleansing. You maybe only care about certain columns. And so you're able to create an AQL.DataFrame function, create whatever data frame you want, return it, and then now you are in the kind of data frame / table system that's expected of the Astro SDK. So we could take this find airflow post function, and or in situations where there's an existing airflow hook, you can even take advantage of that. So, a very common scenario is pulling data from pulling data from Salesforce and putting it into Snowflake or BigQuery or any other database. And that is also extremely easy now, because you could say use the Salesforce API via a Salesforce hook, take the data you need, return it as a data frame, and now it's going to be a SQL table. When it comes to the pulling from data frames, as far as ingest goes, you can either then export it to a file. So let's say you want it as a CSV file in S3. You can take that resulting data frame, pass it to this output file through the export file function, give it the S3 path you want to give it, and then say, I want this as a CSV file or Parquet or ND-JSON. However, if you want to just pass it directly into S3, into a database, we actually offer this output table function where you give us a table where you can give us the con ID and give us the name. So again, here we have a scenario where let's say you want to take Airflow posts. Let's say you want your entire pipeline literally to just be take posts from Airflow, take posts from Reddit about Airflow, cleanse them, pass them into Snowflake as a certain table. You're now able to do this as a single function in Python with just this output table parameter. So this is especially powerful if you are, say, a data engineer that's supporting a team of data scientists. You can create a series of helper functions. You no longer have to know how to create custom Airflow operators. You don't have to know how the Airflow operator API works. All you have to do is create a Python function that returns a data frame, give it the AQL.DataFrame decorator, And now you've created a custom Airflow operator that your data scientists can now use, where you can now multiply your work by an entire team. Now that your data is in Snowflake, let's talk about like doing kind of your silver level transformations, your cleansing, your filtering, your joining. And that's where AQL.transforms come into play. And again, if you're doing a pipeline that's a series of SQL statements, you're going to have to create tables every step along the way. And you're going to have to also like set your dependencies. There's no real way to kind of know ahead of time what those table names are going to be, or so you have to kind of explicitly define the table names. It's not a very Pythonic feeling system. By contrast, if you do AQL.transform, what you can essentially do is make each return value a select statement, and then use regular Pythonic functional composition to say, cool, here are these Python functions, here's how they interact with each other. And so in a situation where, let's say you need to join your posts with a feature table to add certain specialized features. Well, now you can actually just kind of pass in, say, this function takes 2 tables, you pass in 2 tables here, and we actually automatically understand how to convert those table objects into something that can fit within this query. And wherever possible, we use best practices to avoid string injection to minimize chances of any compromising situations. We also have the opportunity, we also offer the option to have an output table in your AQL.transform functions. So for example, if you want the output of this join to go to a specific table rather than going into a temporary table, you just specify whatever necessary metadata needed to create an output table from this post. And as mentioned, you can now compose DAGs using standard Python functional composition. Now, not every SQL statement can fit into a simple DAG file. You might have a SQL statement that's 100 or 200 lines long, and the last thing you want to do is have that SQL statement making your DAG suddenly 1,000 or 2,000 lines long. And so we offer AQL.transform file as a way to kind of allow you to keep your SQL statements separate from the DAG file. You can pass in parameters, you can point it at a file path, and in doing so, you can choose whether you want to keep your DAG file as the single source of truth, or kind of have a more directory-based structure. Now let's talk a little bit about AQL.dataframe again, and how we can use it to analyze SQL tables. Now, one thing that's kind of really nice about what we wanted to create as an experience for the Astro SDK is we wanted the feeling that you could kind of treat SQL tables and data frames as interoperable. So we wanted you to be able to pass a SQL table into a Python function and pass a data frame back into a SQL function. And so here's a good example. We've combined our data via the AQL.transform file function, and now we want to run it against our model. So we're taking our Reddit data and we have like our own model for sentiment analysis to figure out what people are thinking about Airflow at this moment. So we're able to take this combined data, pass it into an AQL.dataframe function. And because you use the typing system to say that this is a data frame, the Astro SDK automatically knows how to extract that data from Snowflake back into a Pandas data frame, where you can then run whatever modifications you want, run whatever queries you want, and get the resulting data frame that you need. And you can even pass that result back into a Snowflake table. So you have this ability to pull data from SQL into Python, back into SQL with very little extra code. And finally, you've done your cleansing, you've run against your model. You now have your inference data, and you need to load it back into a reporting table. So maybe you have a dashboard that shows your daily Reddit sentiment, and you need to load data back into that. You need to merge your new data into an existing SQL table. Well, traditionally, what you would do is you take a snowflake operator and you write a merge statement, and you'd have to kind of manually add all these kind of things. And quite frankly, merges are kind of one of the harder to do SQL functions. They're not the easiest. There's a lot of kind of gotchas in a merge statement, and each database has a completely different way that they do merges. So, everything so far, one of our philosophies has been, we want to make it as easy as possible for you to, pass data, to change databases if you want to. So if you have a Airflow pipeline that's running against BigQuery and you want to test Snowflake, you should be able to take the connection ID for Snowflake, pass that in, and for the most part, with as little change as possible, you should be able to run that same Airflow pipeline. And so merges are a pretty big problem there because they all have their own way of doing it. So what we offer is an AQL.merge and AQL.append function that takes the merge table, you give us the columns, you give us the keys, and you give us the conflict strategy for you. Wherever possible, we'll basically make it as simple as we can to treat things as Python objects and treat things as interoperable between different data systems. So we talked about this entire pipeline end to end, but we haven't really talked about the side effects. So we have this load file, we have this filtering, we have joining, we have merging. But what is the side effect if you're running this DAG 100 times or 1,000 times or 10,000 times? Well, the side effect is lots and lots of garbage temp tables. And that's not fun for anyone. And the last thing we want is for any of you to get really angry phone calls from your DBA saying, why are you filling my Snowflake with junk? What is going on? You need to shut this down. So what we've created is an AQL.cleanup function. And the way that AQL.cleanup works is it actually works as a sidecar to the DAG. It's running in parallel. And what happens is, as long as you add this AQL.cleanup function here, we're able to, in parallel, wait for the entire DAG to complete. And then once the DAG completes, the AQL.cleanup function goes through the entire DAG and will find every temporary table it can, and it will clean it. It will basically do all the deletes necessary, and that way you can run this DAG on a minute-by-minute basis, and you won't have to worry about filling up your Snowflake workspace. Now, let's talk a little bit about testing. As Tamara had mentioned, as of Airflow 2.5, we now have this DAG.test functionality, which is really useful because you can basically pass in a connections file that overrides whatever connections Airflow has with your local connections. And so you can run your DAG locally with kind of customized dev connections or local connections. And where this can get really useful is especially with the Astro SDK. So, you can do DAG.test with traditional operators and kind of see in different ways how the actual operator itself works out. But with Astro SDK, because things are happening in Python functions, you can actually see in the middle of the DAG using breakpoints what your data looks like. So in this case, maybe you're pulling data from some HTTP hook, pass it to a data frame, and now you can see the data frame in your Python IDE. You can even open up an editor in the IDE and play with it, run queries against it, see what it looks like. And so even if you're doing SQL work, let's say you do some AQL transforms, you can temporarily add an AQL.dataframe function that inherits from your AQL.transfer. And now whatever SQL table you created is a data frame that you can test on your local machine. This is also really great for if you want to do some form of unit testing where you can run DAG.test. You can create mini DAGs with your, you can create miniature DAGs with just individual functions, expected inputs, expected outputs, and then use DAG.test to run those as unit tests as needed. The only setup you need to do to use the Astro SDK with the dag.test function, which is actually also just the only setup you need in general, is you need to set Airflow core allowed deserialization classes to airflow.star and astro.star. And the reason for that is that as of Airflow 2.5, we've expanded how we are actually doing our JSON serialization. And in expanding how we do JSON serialization, we just ask users to tell us what are the classes you expect to serialize to prevent any potential injections where someone serializes or deserializes a class you did not expect to be serialized or deserialized. So we've been working on this for quite a while. We've gotten a pretty impressive series of systems we support. So BigQuery, Databricks is a pretty recent one. So we have support for Delta. When it comes to loading, we actually support both autoloader and copy into. We have a lot of cool stuff happening there. Snowflake, SQLite, Redshift. We've recently added DuckDB. And as far as file stores, we have a lot of the standards. We have Amazon, local file system, Google Cloud Storage, Azure, and as of recently, Google Drive. So the big takeaway messages is that we want you to walk away with is Astro SDK opens up Airflow to a whole new class of data scientists and data engineers, especially if you're a data engineer that's supporting a team of data scientists. It makes it really easy for you to build helper functions. It really kind of allows you to stop thinking in terms of DAGs and start thinking in terms of data pipelines. And so the biggest thing is it really, with the AQL.load file, it really minimizes the overhead of the extracting and loading, which can be kind of the nastiest part of a DAG, and allows you to really focus on the transformation side. So your SQL transformations and your Python transformations. We're already up to Astro 1.5. So we've been GA for a little while now. We have customers using this at scale. We are always available. If you post issues to our GitHub, we will respond within a day. This is a very actively maintained project, and we're really proud of this. And we really love for people to start using it and come to us with your stories, come to us with your complaints. We just want to hear from you and make this product as awesome as we can. I want to send a massive thank you to the team that made this possible. And as well as thank you to Tamara for co-presenting this, and thank all of you for joining us. And we're excited to answer any questions you might have in the breakaway room.